Welcome back for another round of retro hacking. I'm your gracious host J-Verse Lewis, and in this video we're going to talk about loops, program loops. Computers are great at doing mundane things over and over again, and loops are just perfect for this task. So I'm going to introduce you to two types of loops. The first of which is available on all Commodore systems. That's the good old-fashioned if-then loop. And I'm also going to talk about the do loops, which are available on the Plus4 and on the Commodore 128. Here with my live Commodore 128 in 64 mode, and let's have a look at the if-then loop. I've been using it many times, and the syntax for it is quite simple. In line 10, we can use it in direct mode as well, it's no problem. We can say for I, any sort of variable, counter variable will do, equals wherever you want to start, like 1 to 10, and then we can do something over and over, like print hello, and then we hit next. And if we execute that, then we're going to see the word hello printed 10 times. So that's fantastic. And we can use that in a program as well. We can use anything in between the for and the next will be executed that many times, and we can do whatever we like with it. And it's a predefined loop, so it's not an endless loop, because we always have to put a finite amount of counting options here into that counter. So it always has to start with a number and it has to go to another number. The only thing we can do here to vary this a little bit is we can count backwards as well. So we can start with a large number and go to a small number. So if I were to, let me just write a little program here, for I equals 10 to 1. If we wanted to do that, then we have to supply the step. So in this case, we have to say step -1. And then in line 20, we're going to say print I. In line 30, we'll say next. If you say next without any parameters, then the loop that was just executed will be kind of looped with the next. But I can also specifically say next I. If I had more than one loop inside each other, then I can specify which loop should be continued at this point. So, but if I don't specify that, that's also fine. So I can say next I, or I can just say next. It doesn't matter. And if I run this, then it shouldn't surprise you that we're going to see the numbers 10 to 1 in reverse order, just like that. But I can also do something with this stepping thing. I can also step it in larger steps. So if I were to go and say for I equals 100 to 1, I could say step -10. And then if I run this program, I'm also going to see 10 values printed out, but they're going to be subtracted by 10 every time. So that's kind of handy. And it works up and down as well. So of course, if I go I equals 1 to 100, and I'll say step 10, then that's going to count upwards as well. Well, actually 1 to 91, very exciting. I can also start with another number. I could start with 0, for example. So 0 to 100, that would also work. And now we're getting 0 to 100. That's a for loop, and again, that's available on all the Commodore systems, and it can be used to great advantages. But we don't have something on the Commodore 64 and the VIC-20 that would create an endless loop. So I could, of course, create something similar if I go and create a new program like the very funky programming example I think that everyone has tried, like Hello World. And in 20 we just go to 10. If I were to execute that, it will print hello world forever. So that is more or less an indefinite loop, and it's important sometimes to have that in programs that run in their own system, that kind of continuously require user input once a big routine is finished being queried. An adventure game is a good example of that, or a calculator that would continuously request user input unless it's calculating something. The run stop key will get us out of this, of course. There is one other thing in this. We could create a loop just without any for and next types of things. If we if we typed line 15, if we'd had I equals I plus 1, and then we can say in line 16, for example, if I is 20, then end. We could do that, and then the program will look like this, and now we're providing our own counter in this, and if that counter is reached, then the program will end and the loop will be exited. So without any other things, it'll print hello world 20 times and then it'll exit or go somewhere else. In our case, it'll just end the program. So very important to remember that you don't have to have fancy tools to create an endless loop. Nevertheless, Commodore was kind enough to introduce such a loop, which is available in other programming languages as well. And I think that's what their idea was, that they wanted to make BASIC look and feel a little bit more like other procedural or structured programming languages. And that's where they come up with the do loops. Let me show you this in Commodore 128 mode. And the do loops, they take on this format. They do work in direct mode, but it's much easier to explain this in a running program. So in line 10, you could say do. Anything between these lines, like print hello or hello world, will be executed until sometime below that, we're going to say loop. That's a do loop. So it starts with do and it ends with loop. And if I do that, then it'll just do that forever. Basically, do and loop. There's no conditions attached right now. So that's more or less exactly what I've just shown you with the goto command, that it always goes to back to the beginning of the program and runs itself. Run stop will get us out of this. But the good thing about the do loops is that they have conditions as well. So I could say, if I in line 30, if I say I equals I plus 1, this is more or less exactly what we did before. And in line 40, I can say if I equals 10, then exit. So that is something else we can do. And in line 50, we're going to provide the loop command. So this is what our code looks like. Do print hello world, increment a counter, and then if the counter reaches a condition, then we exit the loop. And then, of course, yeah, we can also in line 60, we can say print perhaps that's it, folks. And if we do that, we can see hello world 10 times, followed by that's it, folks, to signal the end of the program. But that's kind of cheating, and the do loops, they provide a better way of adding a counter. One way is to add a counter at the beginning of the loop. So where we say do, we can say do while. We're using I, yes. I is smaller than 10. And then here we just say I equals I plus 1. Line 40, we're just going to take out completely. Whoops. Entirely, so then we're left with this. So we still have to provide our own counter, but the initialization of that is at the top. So if we run this, which is actually, yeah, it's gonna say that's it, folks, because I have to specify the if I is larger than 10. So there we go, because we start the program with I is 0, and now we're going to see, oh, that's it, folks. How interesting. Yes, of course, because see, I was right the first time. It's one of those things. There. Let's try that again. Hello world 10 times, followed by that's it, folks. So that is what the do loop does if you add a condition at the top with a while counter. So sometimes this is also called a do while loop. And the other way would be the do loop until. So the other way of doing it is in line 10, I'll just say do. And in line 50, I'm going to amend this with loop until x is smaller than 10. So that's probably also not going to, yeah, exactly. It does it once, and then it says that's it, folks, because for the loop is going to be executed once for sure. And the counter being at the end means that we can check at the end if we wanted to repeat this loop or not. So they do have their uses, and if I wanted to create exactly the same as I had before, then of course I'm going to have to say if x is larger than 10 in this case, which won't happen until x is in fact 10. And there we go. In fact, why is this happening? How interesting. I equals I plus 10, x is low. Yeah, because I should perhaps query the correct variable. There we go. That's what I was looking for. So those are the two types of loops, the if-then loop and the do loops. And the do loops can either take an exit statement, like an exit command that'll be executed as soon as a certain condition is met inside the loop, or they can have a condition at the top when we say do while something happens, or we can put the condition at the bottom when we say do loop until. So those are the things that have been introduced. So yes, and this is going to work on the +4 as well as on the Commodore 128. That was it for today. Have fun with loops in Commodore BASIC. If you like this video, then please share it with friends, family, and total strangers, and anyone you can find in the retro crowd. Tell them how amazing Jay's videos are with loops and all other kinds of funky things. And if you liked my videos in general, please subscribe to my channel, and I will see you next time. Take care. Bye-bye.